Welcome to Code Legends. If you're enjoying the content, please support the channel by subscribing and liking the video. Now, let's get started. Types are a basic part of JavaScript and affect how we write our code. But because JavaScript has a dynamic type system, it's easy to make mistakes. For example, you might try to use a property that does not exist, or mix up a number and a string. We've all seen that annoying error that says undefined is not an object, right? TypeScript helps you avoid these issues by checking your code while you write it. It builds on JavaScript by adding some extra syntax to define types and includes a compiler that turns your TypeScript code into regular JavaScript. In a way, it works like a mix of a compiler and a code checker. While you're coding, TypeScript checks for type errors and lets you know if it finds any issues. Once you've finished, it converts your code into JavaScript that works in browsers or environments you might need. Since TypeScript is a superset of JavaScript, any JavaScript code you write will also work in TypeScript. This means that you don't have to switch your whole project to TypeScript all at once. You can install TypeScript and keep using your JavaScript files and gradually convert them to TypeScript over time. This way, you get the advantages of TypeScript without needing to rewrite everything right away. It's no surprise that TypeScript has become so popular. Developers love how it adds type safety while keeping the flexibility that JavaScript offers. Here's another reason to consider using TypeScript. It acts as a static validation tool, similar to ESLint. Tools like these are designed to give you more confidence in your code by ensuring it works as intended and helping you catch potential bugs early. TypeScript understands how the types in your code are connected, which means it can help you avoid many common errors. It also provides helpful hints as you write, guiding you to write your code correctly. While TypeScript doesn't replace tools like ESLint or automated tests, it adds an extra layer of confidence by catching your issues before you even run your code. TypeScript gives you confidence that your program is working correctly, while tools like automated tests can ensure it behaves exactly as you expect it to. TypeScript also works as a compiler. Similar to Babel, it can convert both TypeScript and JavaScript code to be compatible with older browser engines such as Internet Explorer. So if you need to run your code on Internet Explorer, you can count on TypeScript to compile your code to be compatible. If you're only targeting newer browsers, the compiler will simply remove the type information and leave you with standard JavaScript code. Remember, TypeScript is not a runtime language. All the types you define are stripped away during compilation. Its main purpose is to help developers like you use types and add checks to their code, reducing errors and potential bugs. You can think of TypeScript as a way to enhance JavaScript progressively, adding more structure and safety without replacing it. TypeScript is a superset of JavaScript, meaning any JavaScript code is also valid TypeScript. This includes the huge library that NPM offers, even though when you're using NPM libraries without proper type annotations, many JavaScript programs will likely have type errors, and to make transitioning easier, you can configure TypeScript compiler to ignore these errors while gradually updating your code base. As you start writing TypeScript and converting your files, you can identify and fix any hidden type errors in your code. Since TypeScript builds on JavaScript, it carries over many of the JavaScript quirks. This means that there might be time when adding the right type annotations isn't entirely possible. Luckily, TypeScript offers escape hatches like the AnyType that we're going to discuss later, which lets you bypass type checking for certain parts of your code. This works just like writing plain JavaScript, allowing you to maintain the flexibility of dynamic typing. However, using this means you lose the assurance that your program is completely free of type errors. If you're looking for a fully strongly typed language that compiles to JavaScript, you could look into options such as Rescript or Elm. Let's talk about working in a new code base, which might feel overwhelming, especially when you're unsure how the pieces fit together or how certain parts should function. Adding type annotations to your code can simplify this process, reducing guesswork and providing clear guidance for anyone navigating your code base. TypeScript is also a great tool for refactoring. In plain JavaScript, it's hard to track all the places that needs update or when you make a change. With TypeScript, it automatically checks your changes across the whole project and alerts you if you have any issues. This means you can identify and fix each warning without having to run your code to catch every problem. Other thing that I want to mention is that TypeScript is widely used in the companies as of now. So if you're trying to get into the industry, this is definitely a time that you might need TypeScript. So it's never late to learn it. I really suggest you start doing it now because TypeScript helps you write code with fewer errors by catching issues before you even run it. Setting up the type system and adding type annotations might take some effort, but trust me, it's absolutely worth it in the long run.